And thank you for the organizer for inviting me to open this year's Georgia Lucas conference dedicated to climate change economics and knowledge. There is a problem with the, should I take the mic? Yeah, better? Okay. So what I'm going to do is to try and offer you in the next 20 minutes, hope to make it, a feeling of what's inside the large, fast evolving box of climate change economics. A 2023 survey, a very recent survey conducted by the Policy Institute of the King's College in London as part of a Horizon Perizia project, specifically on the perception, on public perception and knowledge about climate change, confirms that there are very wide misperceptions on the scientific knowledge of climate change. To the question of, to the best of your knowledge, what percentage of climate scientists have concluded that human-caused climate change is happening, we see that the average estimate of the proportion of scientists indicated by people has convinced that climate change is taking place and it is human-induced, is anthropic, is around 68%. Enormously lower than the reality, which today is 99.9%. On other questions, emerges that 3/4 of people, about 74%, say that climate change is mainly caused by human activities, which means that 26% think that it is not. Things go a little bit better in Italy, surprisingly not in Northern European countries. Well, despite remaining this perception and lack of knowledge, the large majority of people are worried about climate change. 81% of people on average. This survey pertains 6 countries in Europe plus the UK, in the European Union plus the UK. So it's not all of Europe, but it's already pretty representative. It says that, answers say that more than 80% of people say they are worried about the impact of global warming for future generation, for humanity in general, and a remarkable 62% of people in European countries, in the European countries covered by the survey, say so not just about the world in general, including developing country, but also about their own country. So the perception is there that it is a serious problem. Yet, actions to mitigate climate change don't match the public perception of how serious the problem is. Under current policies, there is a remarkable emission gap, which means that there is a large difference between the total global CO2 emissions from least cost scenarios that would keep global warming under the stated objectives. Here we see, can you see the point? No, you don't. I have to use this one in order you to see. Yes, you see it. This is the trajectory we would need to remain within +2 degrees of warming. This is the trajectory, the orange one, to stay within the 1.8 warming. And the last one down here is the 1.5 degrees trajectory. Under current policies, we are heading here, which means that the emission gap is pretty large. And remains larger even with the new pledges. The Glasgow, the pledges made by countries under the Glasgow Climate Pact, plus all the officially announced mitigation pledges for 2030, which were added later on until last year. All these pledges, internationally agreed, make it to reduce projected emissions to 2030 by only 7.5%, whereas staying within the +2 objective of the Paris Agreement would require a reduction of 30% with respect to previous pledges, and the Glasgow objective of 1.5 degrees warming would require a 55% reduction. So we are indeed moving very, very shyly. So why so little, so late? Economics may help. Climate change economics does make the effort to help us understanding why. And the first reason why we are doing so little and we are going so slowly, is obviously the real cost of leaving fossil fuels in terms of jobs, purchasing power, welfare effects. We're going to go a little bit deeper into these later on. A second important answer is the fact that climate change is a global problem for which damage is disjoint from the location of emission sources. The incentive for individuals and even for individual countries to refrain from emitting greenhouse gases is very small, and the effort of one country in isolation can be nullified by unmitigated growth in emissions in another country. Not only countries that unilaterally adopt stricter regulation may face carbon leakage, may lose competitiveness on international markets. A third reason why it is so difficult to act on mitigating climate change has to do with the fact that this particular environmental issue has very intricate distributive characteristics, much more, for example, than the ozone layer problem, which we manage to tackle quite effectively and quite quickly through international cooperation, much more than acid rains or other international environmental issues. Here, with climate change, the question is, in terms of distributive issues, pretty intricate, particularly between North and South and between the West and the rest of the world. Industrialized Western countries are the ones responsible for the cumulative emissions that make today's greenhouse gases concentrations in the atmosphere and have generated the problem. Developing countries are the ones that are going to suffer most and first from the impacts. So no one in developing countries is willing to accept restrictions right now. But many of today's richest countries resist to the idea of being the ones that bear all the costs without the participation of at least those giant Asiatic countries that now challenge today's industrialized countries on world markets. No, sorry, I went on. The last answer that climate change economics is putting forward to why it is so difficult to act for climate change, to do something about climate change, pertains human psychology. Human psychology has an incurable bias towards the present. Decades of behavioral and experimental economics have consistently found evidence of time inconsistency and the use of irrationally high discount rates in people's welfare, in making decisions with impacts that are obviously adverse on people's welfare. We know that individuals are willing to accept smaller immediate rewards over larger delayed rewards, even when the delayed rewards are objectively more valuable. And this is true in individual preferences. For example, we have to force compulsory saving for retirement, and we can think of a number of other examples. It's true in corporate decisions where there is a structure of rewards for executives which has a short-term view, and there is pressure from financial markets. There are issues of competitiveness that induce a very short-sighted strategy. And it's true in political processes, as we know, again, where it is easy to imagine why. So if we find it as humans so difficult even to act rationally in front of our, to do questions such as to do our homework, let's imagine how it works when it comes to facing an epochal massive transformation of our socioeconomic systems. Now, there is a lot that climate change economics can do for us in matter of climate policies. As economists, to decide what to do. First, we want to know what's the cost of carrying on business as usual and bearing the impacts. And on the other hand, on the other plate of the scale, what's the cost of doing something to avoid those impacts? So the first thing that climate change economics perhaps tries and do is to start from evaluating the forecasted socioeconomic impacts from climate change. This is done through several, in fact, different approaches. Older studies tend to rely on enumerative studies. These tend to take simply number of possible impacts in terms of their physical units and to multiply them by the evaluated unit costs economic terms and then adding them up. Then there are econometric studies. Of course, I mean, enumerative studies do not take into account the interactions, for example, price changes, the dynamic aspect of socioeconomic impacts of climate change in the future. Econometric studies are a second approach that is used. Econometric studies tend to rely on a sort of cross-sectional approach in which we assume differences in climate existing now between different places to be a good proxy for differences in climate that will take place, materialize over time in the future. And this, of course, is an important limitation. However, they have the advantage they don't have to assume nothing about, for example, adaptation, behavior, and so on, because they observe what is actually taking place and what has actually taken place in recent years or decades in different parts of the world. More popular in recent years are valuations, socioeconomic valuations of the impacts of climate change based on CGA, on computable general equilibrium models. They, of course, have the advantage of being able to look at the whole system and include the dynamic changes, interactions between prices and sectors. One issue is that they tend to be based on national accounting values, and therefore they tend to disregard environmental impacts on health. They tend to express the results in terms of percentage loss of consumption or of GDP, leaving aside other kinds of impacts which may be relevant. Integrated assessment models also is another part, an important part of the literature relies on integrated assessment models, which also integrate computer general equilibrium models inside. And they constitute the base, for example, of the evaluations included in the IPCC assessment reports, starting from the AR5 report. Elicitation studies are simply evaluations built on the interviews on experts, so expert opinion on future impacts of climate change. Well, there are several meta-analyses. One by Toll has been published just a couple of months ago on energy policy. Meta-analyses which produce estimates of average negative impacts from all these different approaches. And they tend to give us numbers, estimates of GDP impact from climate change by 2050 in the range of losses of GDP between 2 and 3% if we stay within a 2.5 increase of the temperature, up to 11% by 2100, assuming we are going to stay under a 3-degree threshold by the time. These results are very sensitive to discount rate used, to the fact that they tend not to include catastrophic risks, but just a sort of the impact of raising temperatures on labor productivity and other aspects such as this. For example, estimates by insurance companies, which do take into account catastrophic risks, tend to be much higher. A recent estimate by Swiss Re points to something like a loss of 18% of global GDP by 2050 under a 3.2 scenarios at the global level, global average. For the European Union, around 11% loss of GDP by 2050. Careful, these are global averages. If we look at how these losses are going to be distributed across the world, we find very large disparities between high-income countries and developing countries. This diagram here shows how the losses would be scattered on this axis. You see income, and on this GDP per capita, and on the vertical axis, percentage losses of GDP. And you can see that the poorer you are, the more you're going to suffer, up to -20, -25, even -30% loss of GDP, expecting in 2050 in the southern world, in poorest countries. And the same is true, you find the same if you look at the correlation between temperature, average temperature. So cooler countries, again, the north of the world, to simplify a bit, tend to have smaller losses, much stronger losses for warmer and tropical countries. Now, mitigation makes a difference. For Europe, mitigation policies limiting warming to 2 degrees would reduce the welfare losses by 70% compared to a 3-degree scenario. Staying within 2 rather than 3 makes 70% less losses, while limiting warming to 1.5 would lower welfare losses by 90%. So it makes an awful lot of difference, spending in mitigation. But mitigation costs. And mitigation involves technological, sectoral, macroeconomic, welfare costs, which again involve an array of methods and models. An important one, which we probably have all heard about, is the system of looking at marginal abatement, building marginal abatement of carbon cost curves. MAC curves look somewhat like this. They estimate the marginal cost of CO2 equivalent emission abatement by sector, associated, which is the height of the column, associated to the relative reduction potential, how much we can reduce with that particular technology, which is the width of each of the column in this histogram. So all the technologies that you see in this part of the diagram are associated to negative costs. It means that on their lifetime scale of that technology, the mitigation cost is negative. They imply a saving. And you can find things such as more efficient lighting system, motor system efficiency, installation of retrofits, small hydro, and so on. And then from here on, you have technologies that cost more and more, and they also tend to be the ones that have the largest reduction potential, with the associated cost per ton of CO2 reduced. Now, aggregating these mitigation costs, I mean, there are models with which we aggregate mitigation costs. This is a rapid, I mean, this is a diagram coming from the 6th assessment report of IPCC, published last year, which offers an overview of mitigation options and their estimated ranges of costs and potential in 2030, so close in time. The results in general equilibrium models tell us that both consumption and GDP losses increase with the more stringent our steady state goal, concentration goal is going to be. We're going to have very high costs for a concentration goal of 430, 480 parts per million target by 2100 by the end of the century, between 2 and 5.7 GDP points of loss, slightly more in terms of consumption. These are mitigation costs calculated as if we started to reduce emissions right now. But anyhow, from this pretty large set of literature, what emerges is that the global economic benefit of limiting warming to 2 degrees is going to exceed the cost of mitigation in a large part, in most of the assessed literature, the literature assessed by the IPCC report. Unless climate damages are going to materialize at the lower end of the range of possibilities, and unless future damages are discounted at very high rates. Of course, all these estimates are very sensitive to the discount rate used. General liquidity models also tell us that mitigation costs increase pretty sharply with delay in starting the moment of mitigation. We can consider, I mean, the models can consider whether mitigation actions planned today are delayed until a future date by missing, and this has as a consequence missing the current climate targets, or whether we initiate later but try to stay within the targets, and therefore we accelerate policies at a later date with, of course, more stringent and thus more costly policies in subsequent years. And depending on the option that we want to evaluate, on average, net mitigation costs increase by approximately 40% for each decade of delay in starting with the mitigation. A delay to 2030 in starting mitigation policies would cause the most ambitious climate targets, plus 1.5 or plus 2, to fall beyond the set of possible levels of stabilization. Another part of the climate change literature looks at adaptation. If we include also adaptation, then we can further reduce the losses. Mitigation and adaptation must be coordinated as they compete in the use for scarce resources. And economic theory tells us that the optimal level of adaptation equalizes the marginal adaptation cost and the marginal adaptation benefits. And it is to say here, where the adaptation curve has a slope of 45 degrees. But again, quantifying adaptation has raises a lot of conceptual issues. For example, the co-benefits from adaptation measures. How should we account for the costs of adaptation if it also has other benefits beyond mitigating climate change, for example, for health or welfare in other forms? What is it that would have taken place anyhow? So a problem of additionality and so on. But certainly also adaptation makes a difference. In the EU, for example, mitigating climate change to 1.5 would halve the damages from coastal and river floods, just to take one of the many forms of impacts. Adding adaptation would reduce residual damages from, for example, river floods by 40 times and by 20 times those from coastal flooding. The massive effort in evaluating impacts and evaluating mitigation costs allows climate change economics to help also setting objectives, and setting the targets. Is another crucial question. Where is it that we want to go? How ambitious it is efficient to try and be in mitigating climate change. Standard economics tells us that we should do something. We should choose decarbonization targets so as to equalize marginal benefit and marginal damage, where the parameters down here are the discount rate and the rate of decay of the greenhouse gases in the atmosphere, which requires knowledge of marginal mitigation costs up to the different moments in time and deadlines, the marginal economic value of impacts, the discount rate, all this kind of this knowledge, which is, as we have seen, very difficult to quantify, makes it very difficult to identify analytically at which concentration level, and therefore, given the decay rate, at which emission level, the discounted damage of an additional unit of greenhouse gases equal the cost of containment. This has been the object of all the debate within international conferences on climate change. Eventually, what we do in the real world is to revert to define the objectives in terms of warming. So decided whether, given the forecasted impact, we want to stay within +2 or +1.5 based on the impact scenarios, converting those objectives in terms of warming into corresponding concentrations between 400 and 500 parts per million of CO2 equivalent in the atmosphere, and then convert these concentrations in emission pathways, steady state levels, and the emission pathways to reach those steady state levels. This, of course, implies a remaining carbon budget. One point of which I would like to bring your attention, even though very quickly, is that Uncertainty here plays a fundamental role. We often disregard this. Of course, choosing a 1.5 target or a 2 centigrades target makes an enormous difference in terms of remaining carbon budget. 400 gigatons with respect to under the 1.5 scenario, with respect to almost 3 times as much if we decided to stay with to accept a warming of 2 degrees. But look at the acceptable probability, how huge a difference it makes also. When we talk about staying within a 2-degree increase scenario, we always assume to stay within that objective with a given probability. We cannot express it in terms of certainty. So, for example, we can say, okay, let's stay within the 67th percentile, so 67% probability of staying, of making it. Or if you want to stay within an 80%, 83% probability, or whether we accept the 50% probability of reaching that objective, the carbon budget, the remaining carbon budget changes completely, okay? Now, staying within a given objective with a 67% probability may sound pretty good, but think of how would you feel if you were to board on a plane which will land in London with a 67% probability of success. Okay, and so knowledge does play a big role. Of course, climate change economics does a lot for us also in terms of designing policy instrument. Think of all the work on carbon pricing. We will talk about carbon pricing today with our winning papers. You can see here how many active initiatives of carbon pricing are there at the moment in the world. But I want to conclude with a final point, which also connects us to what we're going to listen to through the presentations of today's winnings paper. The question of tackling distributive issues. The previous large-scale societal transformations, Industrial Revolution of the 19th century, the digital revolution of the last few decades, have been originated by technological changes and have been driven by market forces. And this is the first time with the ecological transition that we are facing the task to design, to implement, to govern a deep, deliberate structural change, which is not driven by market forces and will have to be driven by collective action. And it's going to take place in a short period of time. The next 9 to 10 years, up to 2030, are going to be decisive. So the necessary transformations, I do believe they have no chance of success if they fail to build around them a sufficient strong legitimacy. And this is not going to happen if we are not going to look and to study and to deepen our knowledge of the distributional consequences in order to ascertain the political feasibility and foresee the necessary compensatory actions. For example, within our department, we have just finished the work on studying the distributional consequences of the extension of the European Union ETS system to road transport fuels, which is going to take place in 2026. And what emerges is evidence of regressivity of this extension for 12 out of 23 European countries, which is something we have to look after and to discuss and to consider and ponder quite with sufficient attention. Now, I think I will stop here and I will leave the floor to today's winning papers. We have a first paper by Lorenzo Sileci, which has studied the fact that implementing carbon pricing to mitigate climate change also brings co-benefit in terms of reduced air pollution. And so it's going to tell us what is happening in one particular case, British Columbia's carbon tax. If we look at who's going to benefit from those co-benefits, how are they going to be distributed between poorer and richer part of the population? This is, of course, context dependent, but it is very interesting to see the results that may emerge on a case-by-case consideration of this issue. Then Alessandra Testa is going to talk about what goes around comes around, the climate economic cycle. Here, the idea is to look at what relationship is there between temperatures and economic activity, how a raise in temperatures affect economic activity and vice versa. And so we'll see what the US case study has to tell us on this issue. And eventually, last but not least, Costanza Tommaselli, Alessandra Testa together with Konstantin Boss, and then Costanza Tommaselli is going to tell us something as deepened and studied how the market structure affects environmental performance, whether merging of companies tends to affect or not the environmental performance in terms of greenhouse gases emissions, and so again, climate related.